So what we are going to see today is how to generate all the permutations, right? How to generate all the permutations. Tell me, what do you mean by a permutation first? What do you mean by permutations? Suppose that I am having an array 1, 2, and 3. How many permutations of this are possible? Can anyone tell? Typically, permutations mean what? Rearrangements. Whatever array has been given to you, how many different rearrangement of this are possible? How many different rearrangements, right? This is what we call as permutation. So corresponding to 1, 2, 3, what more permutations would be possible? 1, 3, 2 is another permutation, right? First one is a permutation of itself. Then 1, 3, 2 is a permutation of 1, 2, 3. Okay. Afterwards, what other can be the permutations? See, you are not deleting anything. You are not adding any number. Just I am rearranging the existing numbers and how many different permutations are possible. That's what I am trying to generate. So 1, 2, 3 is there. Then 1, 3, 2 is there. What else? Tell me, all of you. What other permutations are possible? Tell me that. It can be 2, 1, 3, another permutation. 2, 3, 1. Afterwards, 3, 1, 2, and then 3, 2, 1. Correct? So overall 6 permutations. Okay, so if you are given n unique numbers, n unique sequence of numbers, right? N unique numbers are there inside a sequence. So there's gonna be n factorial number of permutations. I hope all of you are aware of this thing. Tell me that. All of you are aware of this thing. So my point is right now, how I am going to generate all the permutations. What are your thoughts onto that? How I am going to generate all the permutations? 1, 2, 3. Suppose that I start off from this step. Then how I am going to generate all the permutations? Anyone? Anyone? Okay, fine. So let's do one thing. Let's try to think based on my previous generations. Tell me that what is the thing that you are able to observe here? A permutation can start with 1, can start with 2, can start with 3. So any number that is present into my given array can take the first slot. All of you agree with me on this? Any number that is present into the array can take the first slot. So this is what the basis I'm going to make. Correct? Let me say one thing. Okay, so my given array is like 1, 2, 3, right? I want to generate all the permutations here. So what I can try is that I can say fixing 1. Initially 1 is there, right? I'm going to say fixing 1 into the 0th index. Let me try generate all the permutation. So I've just said that whatever number is already there into the 0th index, this is fixed for me. Let's do one thing. Let's go and try fixing the numbers at the first index and the second index. That's what I can do, correct? So 1 is fixed, right? In the current function call, wherever I'm standing, 1 is already fixed. No, you do not need to touch it. Now, whatever numbers can take the place would be corresponding to the first index or the second index. These two numbers, inside these two slots, the numbers can be interchanged. Since in the previous function call, 1 has already been fixed in the subsequent next function calls, right? This number at the 0th index, they cannot be changed. Okay, do keep that into the mind. So what I can say is that at the 0th index, 1 has been fixed, correct? Now my turn is try fixing the number at the first index, correct? Every number has to be there. Inside every of the index, a number has to be present. What are the choices for me? I'm going to explore them all. So I just said that in the previous function call in the 0th index, let me try generating all the permutation that start with 1. So I just fixed 1 there. Then I came to the next function call. This is responsible to fix the element at the first index. So 2 is already there for me. 2 is already there for me. Let it be as it is. Let 2, keeping 2 in the second index, right? How many permutations can be generated? So let me fix 2 in the first index and I'm going to go here and I'm going to say, okay, fine. So 1 and 2. 2 has been fixed into this function call. 1 has been fixed into this function call. Don't touch them. You are left to just have the choices at the last index of my given array. Whatever is the array, you are just left to fix the last index number. So only one choice is there. It towards its right, no number exists. Towards its left, whatever numbers are there, they have already been fixed. Their positions are already fixed. They cannot be changed. So I am just left with a single choice. Whatever number is already there into your into your what? Into your last index, right? Let that be as it is. And I just say that 1, 2, 3. 1, 2, 3. These three numbers have been fixed by the three function calls subsequently, right? And I am left to have no numbers afterwards. Okay. What I am trying to do is that, okay, Sudhakaran, any question you are having?
These things are already solved by Amir in last session, right?
Permutation have been solved.
Subset. This is similar to subset, right?
This is actually a little bit different question as compared to that of the implementation is quite different. Okay.
Okay.
Okay, go ahead. Let's go ahead. Okay. So what can happen is that, tell me. So basically, how I can try representing the function calls? Can anyone tell? Can anyone try to guess onto that part? In the first function call, you are trying to fix the 0th index. In the second function call, you are trying to fix the first index. In the third function call, you are trying to fix the second index. And here, whenever my index value reaches, you are right now trying to fix the third index, right? That is, index has gone equal to that of n. What does this indicate? What does this indicate? What does this function call indicate? Can anyone tell? You are trying to fix the third index, which is a non-existent entity. Am I correct? Third index does not exist. That means whenever the function call is trying to fix the nth index, that means all the values from 0 till n minus 1, they have been fixed. I have successfully arranged the numbers in 0 from the 0th index till the n minus first index. So this is a permutation for me. Whenever I'm hitting the case that index equal to that of n, I am hitting actually the base case that no more number is there for me to fix at the nth index because nth index does not exist at all. That means from 0 till n minus 1, numbers have been assigned to the respective indices. That means we are already there with a permutation. So whatever is the content of my array, print it. 1, 2, 3, one of the permutation possible, print it, and I'm going to return. Whenever I'm hitting the base case, whatever is my array, I'm going to print it, I'm going to return to the previous function call. Okay, tell me, in this function call, you are trying to fix index equal to 2. Any more choices you are having? We already know that before the second index, the 0th index and the first index, they have been fixed. We are not having any elements. We cannot actually touch these elements because they are fixed by the previous function calls. That's what the convention we are following. Correct. Now what can happen is that whatever is the content of the second index, that can be fixed, or towards its right, whatever are the unfixed numbers, right, they can be put into the second index. These things can happen. But I know that into my current function call, wherever I'm standing, towards the right of the index 2 element, no element exists. This is the last element. So no more choices to be fixed into the second index. I am going to go back to the previous function call. Now what can happen here? Tell me that. In the previous function call, index equal to 1. Tell me what should I do in this case? You were already having, you have here in the current function call, I just said that 2 would be fixed as the first index element. Now what should I do? See, if you are standing at this function call, that means you are trying to assign element at index 1. Okay. And after I am fixed, the next subsequent function call is going to make. So fixing 2 at its place, how many permutations were possible? We have just explored that. As of now, only 1. Okay. Then what else I can do here? Anyone? What else I can do here? At index 1, 2 has been fixed. Okay. Now, can I say that, okay, fixing 2, whatever were the possibilities explode, can I try bringing 3 into my index 1? Is it possible? Only 1 is corresponding to the current function call. Only one entity is fixed. That is 1. Now, index 1. From index 1 onwards, the elements can be assigned. This is what the permutation function calls are looking like. So fixing 2, exploration is done. Now, I just say that towards the right of 2, there is an element 3. Bring it to the index 1 element. Do this. Then what's going to happen? Tell me that. What's going to happen? If I swap 3 and 2, the array is going to look like 1, 3, 2. The array is going to look like 1, 3, 2. Correct? And then what would be happening? Tell me. The array is going to be looking like 1, 3, 2. Now 3 is fixed into the index 1 and you call for the next function call. That okay. Here in the next subsequent function calls, 1 and 3 are fixed as the entities of 0th index and the first index. And do one thing from index 2 onwards, right? Try allotting the elements to generate the permutation. So again, at index 2, firstly, whatever is the content of index 2 itself, right? 2, just fix that as it is and call on for the next function call. Whatever is the existing content, I can definitely keep it and I can try generating the permutation. So what's going to happen is that 1, 3, and 2 is there. And right now in the next subsequent function call, I'm going to just say try fixing index 3. That is an inexistent index of my given array. Typically all the index, whenever index is hitting the case of 3, all the index from 0 till n-1, they are getting fixed into the respective indices. That means all indices into my current permutation have been allotted some value. So whenever I'm hitting the base case index equal to 3, you are not left to have any allotment, okay, to be done. No allotment into any of the indices is done. That's why you are standing at index equal to 3, out of bound of entire array. Whatever is the current content of the array, that's my permutation. Print 132 and return to the previous function call. Okay, 1 and 3. Whenever I'm standing at this function call, 1 and 3 are already fixed. 2 has been fixed and then sent to the next function call for the allotment. After 2, is there any element to be fixed? Tell me that. Any element towards the right of 2 is there such that it can be brought into the third index? No, right? This is the last element. So we are not left with any other choices. So go back to the previous function call. Now, right now, if you are standing at this function call, then tell me any other choices you can have for index equal to 1. Any other choices you can have for index equal to 1? Tell me that. Fixing 2, right? From index 1, right? What elements I can try bringing to index 1? What is the existing content of index 1? Until n-1, one by one, all the elements from index 1 till index n-1, they can be brought to the index 1 to fix and check what permutation can really exist for us. What permutation can really exist for us. Okay. Then tell me what would happen here. Then tell me what would happen. All the choices that can be there at index 1, fixing 2 and fixing 3, both of them have been explored. And right now, after 3, 3 is the last element that can be brought in. After 3, there is no more element towards the right that is left. So I can straight away go back to the previous function call. Okay. So now fixing 1 at this particular index, this particular function call is responsible to fix the element at index 0, fixing 1 at index 0. How many permutations are possible? We have all explored them. Next, what should I do? Tell me that. Next, what should I do? So I think right now, since in the next function call, right, there was a swapping that has been done, 1, 3, 2, right? 2 and 3 have been swapped. So this should be reflected into the original array as well. Array is 1 only with which we are dealing, correct? Array is 1 only with which we are dealing. So what can happen is that since the swapping has been done at a point of time into any of the function calls, so original array right now would be looking like 1, 3, 2. Original array would be looking like 1, 3, 2. Tell me now what should happen. Tell me now what should happen right now. Okay, fine. So we should not, okay, fine. Original array, I feel, should not be affected in that case because, yeah, what is our convention is? The convention is that firstly, fixing 1 at its position, how many permutations are possible, explore them all, then bring 2 in place of 1, then bring 3 in place of 1. So even if you are changing into the next subsequent function calls, right, the original array, whatever is the state of the array in the current function call, that should be retained. This should not be distorted at all, right? This is what we should be always maintaining. Okay, fine. Then what should I do into the current function call? Tell me that. Into the current function call, what should I do? Anyone? Into the current function call, what should I do? You are right now standing at index equal to 0. So 1, fixing 1, how many possibilities explored? Can I just say right now, try bringing 2 in place of 1? Swap 2 and 1. Try bringing 2 in place of 1. So swap 2 and 1. What's going to be the content then? Anyone? What's going to be the content then? So right now into the current function call at index equal to 0, whatever is my current function call, here I am doing the swapping. So I'm just saying that 2, 1, 3 is the state of my array. Now fixing 2 at the 0th index, how many permutations are possible? Let's go on and try exploring that. Okay, so at index equal to 0, this has been fixed. Now go ahead and say, this is the current state of the array. Try fixing the element at index 1. So first choice, whatever is the current content of my index 1, right? Keep it as it is. Don't touch it. fix the current element that is already at your index 1, and go ahead and try fixing the element at index 2 in the next function call. That's what we can do. So only one element can be fixed at index equal to 2, because here 2 has been fixed as the content of index 0. Here index 1, whatever is the existing element, that has been fixed as the content of index 1. Correct? Now at index equal to 2, you are not left to have any other choice apart from 3. Only one element left, which is the existing element of index 2. Keep it as it is. You go ahead and try fixing the index third, which does not exist. That means, again, I am coming out of the array. And what does it indicate? All the elements in between 0 till n minus 1, whatever elements are already there, right? They have been fixed. So I got a permutation. I'm going to print it, 2, 1, 3. Another permutation I have printed. Okay, then what I should say? Okay, fine. From here, nothing needs to be fixed. I can just print the output, print state of my current array. I can go back to the previous function call. I can go back to the previous function call. Then what's going to happen? Tell me that. After 3, no elements. So nothing can be fixed into the index 2 position. Go back to the previous function call. Whatever is the only choice, I am done. And I can go back to the previous function call. 1 has been fixed as the content of index 1. Then what can happen next? Tell me that. What can happen next? 3 can come in place of 1. Since 2 has been fixed into the previous function call, so 1 and 3 can be both present into index 1 from this function call onwards. So firstly fixing 1, what can be the permutations? Now fixing 3, what can be the permutation, right? This is what I need to explore. So fine, I just swapped 3 and 1. So my array changed to 2, 3 and 1 in this case. My array changed to 2, 3 and 1. So right now at index 1, 3 has been fixed as this function call indicates. It's going to only assign the values for index 1, right? Then what can happen next? Tell me that. What can happen next? 3 has been fixed. Call for the next function call that assign the value for index 1. From the next function call onwards, try fixing the values of index 2 till index n minus 1, whatever are left over, right? So 2, 3, 1 is there. I am trying to fix the value for index 2 onwards. Only one choice I can make. Whatever is the current content, just keep it, because no more elements are existing towards its right. Not possible. Then what would happen next? 2, 1, 3 is there. You go to index 3, correct? 3 has been fixed into the current position, and right now I am out of the bound of the array. No, this particular index does not exist. What you are trying to, where you are actually trying to assign some value. That's it. Whatever is the current permutation, print it. 2, 1, 3 got, sorry. What is it, by the way? Okay, I'm sorry. It's not 2, 1, 3 here. It's 2, 3, 1, right? It's 2, 3, 1. So 2, 3, 1 is here because 2, 3, 1, 3 got placed into the first index. Then I'm left off to have only 1 into the last index. Whenever I'm coming out of the bound of the array, it's going to be 2, 3, 1 only. Print the current permutation, right? And return. Whenever you are filling the nth index, that means all the elements at the respective values of indices 0 to n till n minus 1 all have been assigned. That means you are ready with the permutation. Whatever is the content, print and go back to the previous function call. Okay, corresponding to this function call, no more elements towards the right reside. I can go back to the previous function call. Okay, corresponding to index equal to 1. Okay, in this particular recursion tree, 2 values were possible, keeping 1 and keeping 3. Both the explorations are done. You can go back to the previous function call. Okay, now what's going to happen from here? Right now I am again into the first function call, right? What is happening here is you were initially at 1, 2, 3, then you bring 2. Then you bring 2 into the first position, and it turned out to be 2, 1, 3. Then what's going to happen next? Whatever is the state of the current function call, array state, whatever it is into the current function call, that would be maintained. This will not change. Then what should happen next? Tell me, all of you. What is the only choice that I am left with? Fixing 1, whatever are the possibilities, done. Fixing 2, whatever are the possibilities, done. Then what would happen? Afterwards, only one choice, fixing 3, right? Whatever is the content of the last element. Firstly, whatever is the existing content of 0th element, kept it as it is. Then whatever is the content of the first index, right? This can be placed at the 0th index, and then I can try exploring the permutations. Whatever is the content of the second index at last, you can just try placing it at the 0th index, and you can try exploring how many permutations are possible. This is the last choice I can have. All the 3 elements can one by one replace the 0th index, and can try, from there onwards, we can try exploring that how many permutations are possible. So I'm going to say do one thing, bring 3 into the 0th index, whatever are the, and I think 2 would be swapped with 1. So it's going to be 3, 1, and 2. This is the existing state of my array. And at the 0th index, 3 has been fixed as the first element. Okay. Then I just go on and try fixing the element for index 1, right? 3, 1, 2 is the current state. So two choices for index 1. 1 can be there, 2 can be there. Fixing 1, which is already there, what can be the number of permutations I can have? Let's try exploring that first. So I can just say, go on to the next function call and try fixing the second index element. We know that index 1, index 0, both have been fixed. So only one choice for index 2, whatever is the current content. And whenever I'm hitting the base case, all from 0 to n minus 1, whatever all the values whenever have been assigned, whatever is the current content of the array, just print it. So it's going to be 3, 1, and 2. One permutation explode. Return, and okay, since I was having just a single choice here, again return to the previous function call. Then what would happen next? Tell me, all of you. What would happen next? What would happen next to this? Fixing 1 at the index, fixing 1 at index 1. How many permutations possible? Explode. Now I can say bring 2 in place of 1. Bring 2 in place of 1. So it's going to be 3, 2, and 1. Correct? Go ahead. Now 2 has been fixed at index 1. Go ahead and try fixing the element at index 2. So it's going to be 3, 2, and 1. Since 2 has been fixed into the previous function call, right now, whatever are the choices from index 2 till index n minus 1, I'm going to bring them all into index 2. That's what I'm going to do. Okay. Then tell me what would happen. Then tell me what would happen at index 2. 3, 2, and 1 is the current content. I'm trying to fix it. So 1 is the current content, fix it. And just say that 3, 2, and 1, right? 3, 2, and 1. Since 1 has been fixed again, I am at the base case where I'm trying to assign the value at index 3. This is indicating that from 0 till n minus 1, all the values have been fixed. Correct? So 3, 2, and 1, whatever is the current content of my array printed, that's my permutation. That's my permutation. So 3, 2, and 1, that's also printed. Go back and then again go back. Okay, because after 1, there is no more element that can be replaced here at the last position. Okay, fine. Then what's going to happen? It's fixing 1, and fixing 2 at the first index, whatever are the possibilities, explode them all. We got 2 permutations, 3, 1, 2, and 3, 2, 1. I can straight away go back to the previous function call. Okay, so I think fixing 3 as well, whatever are the possibilities at the to generate the permutations, that also explode, right? And here what happened was that the last index element got replaced, and after this element, right, after the last index got replaced into the 0th position, no more element towards the right resides. Not possible. That means fixing 1, fixing 2, fixing 3, whatever were the choices for me, I have explored them all for index I equal to 1, and I can straight away return from here. I can straight away return from here. All the 6 permutations have been generated. Tell me that. All the 6 permutations have been generated. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, and afterwards 3, 1, 2, and 3, 2, 1. All the permutations have been generated. All the permutations have been generated for us. What is the main thing? What is the main thing here? How to generate all the permutations? Suppose that the current function is dedicated for fixing the ith value, and you are having overall n elements into the array, right? Then what you can do is that here, what you can do is there, I can try at the ith position, how many numbers are eligible. The ith number itself is eligible. The I plus first element can come at the ith position, right? The I plus second element can come at the ith position. The I plus third element can come into the ith position till n minus 1. All these elements can replace the ith element one by one and can try forming the permutation. Fixing all these elements at the ith position, how many permutations are possible. Remember that 0 till I minus 1, all these elements have already been fixed prior coming to this function call. Okay, so they need not to be replaced. Do keep that into the mind. How I can try writing the code for this? I can just say do one thing. For I, okay, for index that is starting off from I, then I can just say index is lesser than n. Then I can just say index plus plus. Do one thing. Swap the elements that are there into my arrays index, correct? And sorry, arrays index with array of I, the index I am targeting for fixing the value. And then right now, whenever the ith element has been fixed with the index element, right? I can straight away say, okay, right now, after this current swap, the ith element have been fixed with a certain value. You call for the function go on. When ith element is fixed with the index element, right? You go on and try exploring how many permutations are possible by fixing from I plus first index onwards, and the length of the array remains as it is. That's it. Whenever you are fixing the ith element, you have to do one thing. You have to call for a new function call that's going to be fixing the elements from I plus 1 till n minus 1, right? And afterwards, what's going to happen? Whenever all the explorations are done, fixing the ith element with the index element. Whenever all the explorations are done by this function call, you are going to be coming back. It's going to Then whenever I come back, the flow of control would be inside this current function call. The loop is gonna rerun. Your index would be increased, right? Your index value would be increased, plus plus. Whatever is the next index element, that would be replacing the ith element. And you're gonna be, then at the ith position, index plus one element would be replacing. You're gonna again call a function call. That okay, right now with a new value that I am having at the ith position, right? Go on, try fixing the I plus first position element, right? Go on from the next function call onwards. Go ahead and try fixing the I plus first position element and try exploring again that how many more permutations are possible. This is what is the strategy we are going to employ. First, tell me that, is it clear or not? Are the function calls clear or not? Tell me that first. Are these points clear? First, tell me that. Are these points clear? First, tell me that. Let's write the code also. Right. Let's write the code also. Okay, so let me. Okay, fine. So let me have an array, and that is gonna be equal to that of 1, 2, and 3, let's say initially. And let me just say that let's call the function, right? Permutation. Let me call the function permutation. Inside that, what I can do is that I can just pass on from what index, from index 0 onwards, I should start fixing the elements, and then till n, right? The length of the array would be n, so it's going to be anti n equal to that of array dot length. Okay, the array's length I have passed, and then I can say pass the array as well. Pass the array as well, because inside this array only I'm going to make the changes. So let's have public static, and then I can say void. It does not return anything, but with the help of function itself, I have to print the permutations. Public static void, and then what would be happening? Tell me. Public static void permutation, right? And it takes few things. What are that? It takes at what index right now I'm standing, what index I'm trying to assign some values, what is the current element, okay, what is the size of the array, and I can just say int array. What is the array, what I'm dealing with? Firstly, what is the base case where I have to stop? Whenever index surpasses the n minus first index, whenever index reaches the nth value. Here, this condition is indicating that fine, if I am trying to fix the nth value, then definitely from index 0 till index n minus 1, every of the index have been assigned some numbers that are present into the array. No need to assign any more value, because nth index does not exist. Typically, it indicates I have came out of the bound of the array. So what I can do is that I can just straight away go ahead, try printing the content of my array, I less than an I plus plus. Whatever is the content of my array, just try printing it. System.out.print array of I, give a space, and afterwards print the next line, system.out.println, give an empty print statement, and straight away, okay, I'm sorry, not here, right? Not here. First print the entire content of the array, that is indicating my permutation. I can just say then go to the next line, so that the next permutation can be printed onto the next line, and just return from here onwards. And just return from here onwards. What else I require to do? If suppose you are not at the nth index, you are at the n minus first index, let's say, or you are any index before, then what should I do in that case? I should fix that particular slot, right? I should fix that particular slot. What should I say is that for int I that starts off from index onwards, I less than n, I plus plus. Because I know that right now, right now, the index idx needs to be fixed with some elements. What can be the contents there? Whatever may be the existing element residing at the index, or from index plus one, from index plus two till then minus first index. Any element can come and replace this position. I would fix them one by one and would call on for that fixing this element at the index position. How many permutations are possible? That's what I'm going to do. So the I that starts off from index, how should I swap? Int temp that starts with array of I, let's say. Then I let us say that array of I would be equal to that of array of index. What actually I'm trying to bring in. And then what should I say? Array of I would be equal to that of array of index. Let me just see. Okay, fine. Anyhow, this is the index what we are trying to assign, right? Or let's say that array of temp would be equal to array of index. Array of index would be equal to that of array of I, wherever ith pointer is standing. And then what should happen? Array of index, array of I would be taking the value of temp. Swapped both of them. After the swapping is done, I'm gonna say at the index position, right? The ith element has been fixed. The ith element have been fixed. Fixing it. Okay. Then in call on for the function call again. Now do one thing. Call on for the permutation function call, that utilizing the same function, try fixing all the elements from I plus 1 till n minus 1, where ith element is the current content of the current index inside the current function call. So right now permutation would call on from I plus 1. It will go for that. Okay. Oh, the size still remains fixed and array is as it is, right? With a change state of the array. Whatever is the change state, I have just swapped two elements, and whatever is the current state of the array, with that, I'm passing it on to the next function call. That's it, right? To the next function call. That's it. I feel I don't think anything else needs to be done here. Let's see whether we are able to bring the results or not, or we are doing something wrong. Let's see. Okay, we are able to print only four permutations. Why is it so? Can anyone tell? We are able to print only four permutations. Any mistake that we did? Any mistake that we did? What are your thoughts onto that? Why only four? Array 0 in an array, right? Okay. Why only four permutations got printed? Anyone? I think at least some more permutation should have been there. Why they are just going ahead for the four time function, four time calling the permutation? Why only four times it is printing? 1 2 3 1 3 2, they are getting printed well. Then what is happening, by the way? Then what is happening, by the way? Tell me that. Anyone? Okay, see, for one thing, see, inside a function call, if you pass on an array, right, its copy does not get passed. All of you agree with me? From the main function, let's say I pass an array. From the main function onwards, let us suppose I call for a function with an array. Okay, so whatever this array of the function call f, this is a reference to the original array. You are not passing it as a copy. You are not passing it as a copy. This is just a reference. So inside this function called f, whatever changes I make into the reference, right, that automatically makes the changes into the original array. So suppose that I started off with 1 2 3, right? Initially I said that fix 1 at the position, then fix 2 at the position, then fix 3 at the position. Print it, print, return, and then you said that here inside this function call bring 3 into the first position. That's what I did. So 1 3 2 is the current state, and then I tried printing it straightforward. Correct? This is what I did. Then this, whenever I'm swapping here, right, bringing 3 into the position, automatically, since this array is serving as a reference to the original array in the previous function call, automatically your original array would be changing to 1 3 and 2. Automatically this array is going to change. Okay. Then 132 till this point, right? The permutations are getting printed well. Then what would be happening next is whenever you go back to the previous function call, right? What would happen here? Tell me what would happen. What would happen here? 132. Then you said that fixing one into its position, how many permutations were possible? Explore them all. Explode. They were getting correct, right? Then I say that into the next index, whatever may be the element, bring it to the 0th index. So array would be changing to 3, 1, and 2 now. Then you say that go on and try fixing the first index elements. It's gonna be 3, 1, and 2. Whatever is already there into the first index, let that be as it is. Go on and try fixing from the second index onward. So whatever is it, let it be initially. That's my first choice. Whatever is the existing content, let that be as it is. So that's why 3, 1, 2 got printed, right? You went back and then you brought 3, 2, 1 here, right? You brought 3, 2, 1 here. What's going to happen here is, just a moment. What's going to happen here is 2 would be brought into the position of first index here, because fixing 1, how many permutation, then fixing 2, how many permutation. 3 has been fixed into the previous function call. So what can happen? 3, 2, 1 would be here, 3, 2, 1 would be here, and I think 3, 2, 1 would be swapped, and I'm gonna print. So see, first error is I'm not getting this 3, 2, 1. And whenever you are making a swap here, the content would be 3, 2, 1, or original array would be automatically reflected. The original array would be 3, 2, 1 in that case, right? This is what we are. Firstly, 3, 2, 1 is not getting printed even after 3, 1. That's a mistake that we have done. Somehow the mistake is happening here. Moreover, whenever 3, 1, 2 would be 3, 1, 2, inside 3, 1, 2, 1 and 2 would be swapped. The content, the original array would be 3, 2, 1 like this. Once 3, 2, 1 should have been printed, right? I should have been gone back to this particular function call. And from here, I should have brought 2, 3, 1 before. I should have brought, I should have brought the last index content to the 0th index content. So again, the array would be looking like 1, 2, and 3. So typically, I'm bringing the state of 1, 2, and 3 back, what I have already explored from. 1, 2, and 3 was my original state. And corresponding to this, whatever changes I make, right? Whatever changes I may make, that should be reflected. So after changing into the states of 1, 2, and 3, 1, 2, 3, and 1, 3, 2, this permutation I already got. If I go ahead and try exploring from here onwards, again, I'm going to get the final permutations as 1, 2, 3, and 1, 3. So these mistakes we need to fix. So let's see where the changes actually went wrong, right? Where the code actually is running wrong. Let's try that. So yeah, array passed on as it is. Then what's gonna happen next? I plus plus, I have just passed on the index. If index equal to that of n from 0 till n, whatever are the content of my array, I'm gonna print them all. I'm gonna say that go to the, after printing the current permutation, go to the next line and return. I don't think any mistake is here, firstly. Then again, at the current index IDX, what element can be placed? Either the ith element can be placed, or till whatever contents you are having till n-1, they can be placed one by one. Any mistake that we are doing here, tell me that. I don't think so. How it's gonna run, by the way, let's see. Let's see that. So initially I called on for f of 0, right? From f of 0 onwards, and here the initial content is 1, 2, 3, right? The current index 0 does not matches the value of n, whatever we are having. So in that case, we just say that this condition will not be executed. You are going to come to this particular loop. What would happen is that initially my I would be pointing here at the index value. Index also points at the 0th index. I also points at the 0th index. Then what happens is that you just assign the value temp equal to that of array of index 1. Afterwards, array of index equal to that of, okay, I am sorry in that case. Yeah, I think that's fine. No problem at all. I think what would be happening is temp would be storing the value of 1. Afterwards, array of index, whatever I'm having here at the 0th index, that would be getting the value of array of I. So 1 would be replaced with the value of array of 0 would be replaced with the value of 1 only, because same element is getting swapped with same element. 1 is getting swapped with itself. There should be no changes ideally. Again, array of I. Again, array of I. What is the content here, by the way? Again, array of 0 would be equal to that of temp, right? 1. So there should be typically no changes, and you straight away called on from here f of 1, where the state of the array remains as it is. Where the state of the array remains as it is. So my I is pointing. My I is pointing from here. The loop would be starting off from I value of I equal to that of the current index. What happens is that at this particular position, temp would be equal to that of array of index, that is 2. Then array of 0, array of 2 would be array of, sorry, array of index, array of 1 would be equal to that of array of I. 2 itself, array of I is 2 only, and then I just say that array of I equal to that of temp. Whatever is the value of array of 1, let that be equal to temp's value 2. So there should be, again, 2 is getting swapped with itself, so no changes. You have fixed element 2 at the first index. So, and then you called on for the permutation function, right? Recursively, that go on and try fixing the element from second index onwards. State of the array is 1 and 2 and 3. Right now the index is pointing here, I is also pointing here. Same thing, your temp is gonna be equal to that of array of index. What is it? 3. Array of 2, right? Array of 2 would be equal to that of what? Whatever is the array of 2, you are trying to swap it with array of I. I is also pointing at the same index, right? Array of 2 would also be equal to that of 3 in that case. Array of 2 again would be equal to that of temp. This is what it's going to happen, and you're going to call on for the recursive function. Go on and try fixing the element from the third index onwards. 1, 2, and 3. This is the content of my current array because nothing got swapped, or every element got swapped with itself. Correct? From this particular array state, value of n equal to that of your wherever is your index, right? Okay, my fault. I'm extremely sorry for this. My fault. It's not the I plus first index you are trying to fix, but if at the index part, right, you have already fixed the ith element, then I should start on to fix the element from index plus 1 onwards. This is what I have to do. Right? Okay, then. This is the mistake we did. So right now we are getting all the permutations. Is it coming? But see, the last permutations is a repetition of itself. The first permutation set, whatever we got. Is it that? The error we have already seen. What is that? The error we have already seen. What is that, by the way? 1, 2, 3, and 1, 3, 2. 1, 2, 3, and 1, 3, 2. Fixing. What permutations are possible, right? Fixing 2 at the first position. We are missing that somehow. What is the mistake that we did? We don't preserve the states. Because how the states are not getting preserved? Because this array is a reference, is serving as a reference to the original array of your main function. Correct? Correct. Then 1, 2, 3 is there. I just said fix the first element. It's again 1, 2, 3. Fix the second element. It's again 1, 2, 3. Print. You came back. You swapped. You swapped 3 with 2. It turned to be 1, 3, 2. You printed that, right? Since 1, 3, 2. 3 got swapped with 2, right? Here the state of the array would be 1, 3, 2. So automatically original array would be reflected 1, 3, 2. Automatically 1, 3, 2 would be reflected. Correct. Then you came back to this function call. What would happen? Whatever is the content of the next index, first index, I'm going to fix that as the element of 0th index, right? So it's going to be again swap 3, 1, and 2. Fix element 1 already. Whatever is there, first fix that. And then I just say that 3, 1, 2 is going to be there. Whatever is the original content of the second index, fix it, print. Go back, bring 2 into the position of 1, right? Swap. So 3, 2, 1 is the next permutation, print, right? And if I am swapping 2 with 1, the state of the array is going to be looking like 3, 2, and 1, right? 3, 2, and 1 originally. Since it is a reference to the previous array, whatever array I have maintained in the previous function call, that should also be reflected. Okay, so 4 permutation printed, and then whatever is the existing content of the last index, bring that to the first index. Index by index content we are bringing to the current index, whatever the function is dedicated to fix. That's what we are doing, correct? So what should I do? See, the states here are not getting preserved. If inside this particular function call, right, I am making some changes, it is automatically doing the changes into the original array. So ideally, after 1, 2, 3, my state should have been 2, 1, and 3, because 2 would be the element that should be coming into the first position, and then it should be going to 3, 1, and 2. Correct? This should be how the states of the arrays should looking like into the first function call, but that's not getting maintained. What should I do in that case? See, here the first changes started to begin. My original array got reflected or got started to get changed from this particular function call onwards. Whenever I brought 1, 3 to, whenever I swapped 3 2, this is the necessity in our case. This is the permutation that should be printed. So that's why I swapped 3 with 2, but I don't want it to get reflected into the original array. So let's do one thing. If you are saying that from 1 to 3, I swap to bring the state of 1, 3, 2, right? And this is ultimately changing the original array. So after suppose the entire permutation is done, after 1, 3, 2 swapping, fixing 2 at the current position, the final permutation would be 1, 3, 2, let's say. The final permutation would be 1, 3, 2, let's say. Then after the work is done, this has been printed, you came back, no more choices. You again came back. Then what I'm going to do is that whatever changes I did here, I'm going to revamp that. I know that the second index and third index element, that is whatever is the content at IDX and the ith element, they have been swapped with each other, let's say. So I'm going to again re-swap them so that whatever were the original elements with at the index element, at the index position, at the ith position, whatever were the original elements, they get back to their place after the work is done. So in that particular sense, what would happen? The state of the array would be entirely managed. The state of the array would be entirely maintained. At any of the function call, whatever state of the array I have left it, that would be maintained. And whenever I am going to go back to that function call, I'm going to make changes accordingly to reflect all the permutation. So after the permutation, entire work with the permutation function is done. This is going to print me the entire permutation from the I plus first position till the n minus first position. Once the flow of control is back here, I'm going to say revamp the changes, swap it again. Whatever are the contents at temp, at index and I, swap them back again. So in that case, whatever were the original elements into the index and the ith position, they get back to their position. Okay. So let me just say that, run it and see how the contents are reflecting here. Okay, I'm sorry. So what we are able to get 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 2, 1, and 3, 1, 2. That's it. All the permutation and our permutations are intact. All are different. No repetition of permutation we are getting. That's it. That's it. Correct? That's it. So how this particular change in code has reflected, let's have a look onto that as well. Let's have a look onto that as well. Okay, fine. So see here, initially you are at 1, 2, 3, right? You fixed 1 into the 0th position. Then you went to fix the first position element. Let that be 2 only. 1, 2, 3, you fix the last element and you printed it. That's it. You came back. Now 3 can come to the position of 2. So I am making a swap here, right? I'm making a swap. So once this is getting reflected 1, 3, 2, this array of the next function call is a reference to the original array, whatever I'm trying to manipulate. So if this is 1, 3, 2, this is also going to go to 1, 3, 2 state. Correct? Okay, then 1, 3, 2, it's gonna be, you are going to fix the last element, whatever is the only element, that's the only choice. Print 1, 3, 2, right? You go back to the previous function call, right? This is the permutation function call I'm making after making the change, after making the swap here, right? Okay, now whenever after executing this permutation function, it comes back to the current function, right? You execute the swap method again. You say that fine. This the index was pointing here, I was pointing here. Now swap them back. Index was pointing here and I was pointing here. Whatever changes I made, right? This is actually distorting the state of the previous function call, which was 1, 2, 3 initially. So swap them back. So the overall array would be again looking like 1, 2, 3. Once I make changes here, right, it's going to automatically reflect again to the previous function call 1, 2, 3. So the state is preserved, right? And both of the permutation have also been printed accordingly. Once the work is done, then you revamp the changes into the state you have already done. 1, 2, 3, then you go back to the previous function call 1, 2. 1, 2, 3 is the array. Whatever I have left off from this particular function call, whatever state I have left off, that is getting preserved. Now from 1, 2, 3 onwards, fixing 1, whatever choices are there, explode. Then you bring 2 into the position. You bring 2 into the position. It's going to be 2, 1, 3. Try fixing from the next index onwards. Fix 1 initially. Then you fix 3 initially into the last position. Print. Go back. Make changes. Make changes. Bring 3 into the position of 1. Swap. So it's going to be 2, 3, 1. 2, 3, 1. So the original array would be reflected again. 2, 3, 1. It's going to be. Original array would also be reflected as 2, 3, 1. Okay, 3 has been fixed. Try fixing 1, last element. 2, 3, 1, print it. That's it. 2, 1, 3, 2, 3, 1. Both permutations got printed. Go back. Okay, fine. Here I made the changes, right? Here I made the changes. I brought 3 into the position of 1. That's why the entire array also got reflected. Bring 1 back to the position of 3. Bring 1 back into the position of 3. What I'm going to say is that right now, it's going to be 2, 1, 3 again. So 2, 1, 3 gets back to its initial state. 2, 1, 3 again, you went back to the previous function call. I left off from the state. I got the state back once I'm back to the function call. Correct? So that's why I'm revamping the changes. With whatever element index, right? The ith element has been swapped with. Once the work by fixing the ith element at the index slot is done, right? Once the entire work is done, I'm going to revamp the changes. I am gonna reswap them so that the ith position index element gets back to their position. And then from here onwards, whatever more permutation can be explored, I'm gonna explore them. Just I have to preserve the states in order to avoid repetition. That's what we have got. Okay, that's what we have got. Are these points clear to everyone? First, tell me that. Generating all permutations. Generating all permutations. Are these points clear to everyone? Tell me that. Are these points clear to everyone? First, tell me that. Are these points clear where we made the mistake and how to fix this? How to maintain and preserve the states in order to generate the permutations? Tell me that. I'm downloading the code. I'm gonna upload that after the class. Tell me that. Is it clear for everyone? The permutation part? How to generate all the permutations? What should be the time complexity? Anyone? What should be the time complexity? If you are trying to fix the nth, okay, if you are trying to fix all the n elements, or let me just say that you are trying to fix the 0th element, let's say, how many function calls from here can generate? Tell me that. You are trying to fix the 0th index element, index equal to 0. How many function calls from here can generate? Fix the 0th index at its position. Okay, fix the 0th index at its position. 0th index element remains as it is. Or you fix the first index element, you fix the second index element, you fix the, or rather, this is a condition how the branches can take place. You just say swap the 0th index with the first index element. Just let me redraw that once. How it can happen is that you just say swap the 0th index element with itself, and from here onwards, go on and try fixing the first index element. Again, another choice, swap the 0th index element with the first index element and go on and try. Just let me write it inside the branch, right? Swap your 0th index element with first index element and go on and try fixing the element for f of 1, right? Okay. Ultimately, after 0, I have to go and try fixing the values for f of 1. Again, what other choice I can have? Swap the 0th index element with second index element. Go on and try fixing the first index element. That's it. At the 0th index, second index element is coming. There's going to be more choices. And at the end, the last choice is going to be swap 0th index element with n minus first index element. And from here onwards, go to try fixing the value of f of 1. This is how the entire function call is looking like. All of you agree with me on this? There's going to be more function calls. So how many from a single function call, how many function calls are generating? From a single function call, how many function calls are getting generated? Tell me that. How many function calls are getting generated? N function calls. From a single function call, n more function calls would generate. In the worst case, n more function calls would be generating, correct? N more function calls would be generating. What would be, so I know that if I am at the first level, right? At the initial level, there is just a single function call. It would be getting multiplied and the next level would be having n function calls. If one function call gave rise to n more function calls. this n, each and every of the n function calls would again give rise to n more function calls. So n square it's gonna be. In the next level, it's gonna be n cube. It's the next level is gonna be n to the power 4, right? And how many levels of function calls we are having in total? In the next level, f of 1. Then after f of 1, it would be f of 2. Then after f of 2, it's gonna be f of 3. What we need to fix till the time we have fixed f of n minus 1. So overall, it's gonna be n levels of function calls, right? So at the end, the last level would be filled with n to the power n number of function calls. The last level would be filled with n to the power n number of function calls. Every function call would be getting executed. Every function call would be getting executed, right? This is what we are seeing. Every function call has to be executed in order to generate all permutation. We have already seen that inside this particular recursion tree, right? There was no function call that was not getting executed. Proper execution of every function call was there, right? Whenever a function call will be called off, it would be doing some work and it would be returning. That means it's completing its execution. So tell me, for in a single function call, what we are doing? In a single function call, what we are doing? Checking the condition, right? Printing. So n operations. In any of the function call, you either print, so n operation for that, or you swap, for the ith position, right? I bring in n possibilities. For the ith position or for the index position, I bring in n possibilities. So effectively, all these are constant operation, calling, swapping, 2 times swapping, and calling the function call. All these are constant. But so overall, inside the block of for loop, I am performing k unit operation at max. But how many times you are doing? In the worst case, for every function call, I perform k into n work. The work I'm performing is some constant k into n. That's what I am doing, correct? Because for every of the function call, there is a loop right now that's running. So that loop depends upon what is the value of n. So some k into n work for every function call I'm performing. This is what we are doing, right? How many function calls are there? How many function calls are there? From 1 till n, then n square. All these are the number of function calls at each level. Now add up them all. From 1 till n to the power n. From 1 till n to the power n. This is the total number of function calls we are getting. So this is a geometric progression again. N to the power 0 plus n to the power 1 plus till n to the power n. All these are giving rise to a geometric progression. So what is the total number of function calls we are getting? It is equal to that of n to the power n plus 1. This is what I am getting. Minus 1, right? The first term is 1 for us. To n to the power. What is the sum of GP, by the way? It is A, then what is the common ratio between consecutive terms? This is differing from its previous term by a factor of n. Then n squared differs from its previous term by a factor of n. So the common ratio between any two consecutive terms is n only. Okay. So R is the common ratio. What is the number of terms? It's n plus 1. N into n plus 1. Then it is coming out to be minus 1. And afterwards, what is the common ratio? N minus 1. This is the overall sum of the GP that we are getting up. Okay, so A is the first term of the GP series. So n to the power 0 is 1, right? So it is going to be overall the sum of the GP we are getting is n raised to the power n plus 1 minus 1 divided by n minus 1. Okay, so typically it is, if I am considering the upper bound, right, then I can neglect all these things. So at max n to the power n function calls I am getting. For each and every function call, right, we are performing some nk amount of work, nk amount of operation. So again, I feel it's roughly around n into n raised to the power n dot k. Roughly, this is the amount of operations we are performing. Put that into the big O. K is a constant you can neglect. Complexity is gonna be big O of n to the power n. Okay. Generating permutation takes approx big O of n to the power n. What is the depth of the function calls we are having? Depth of the function calls is n plus 1. Okay. Maximum depth of the function calls is n plus 1. That means into my call stack. There can be at most n plus 1 function calls at any point of time of program execution, not more than that. So again, since 1 is a constant, I can neglect. Space complexity is also big O of n. Space complexity is big O of n. Time complexity is big O of n raised to the power n. How we got it? We calculated simply what is the number of function calls. This is the amount of function calls, right? A GP series sum. It came out to be approx n to the power m. It came out to be approx n to the power m. And we got that since the depth of the function call is at most n plus 1. So into the call stack, no more than n plus 1 function calls are going to be there. So what's the space complexity? We go off n. What the space complexity is, we go off n. Okay? Not more than that. Fine. Are these points clear to everyone? How to generate all the permutation? How to generate all the permutations? Are these points clear to everyone? And again, if you look at the function call, for every function call, you perform at least nk amount of operations. Either you, if it is a non-base case function call, you do n times swapping at max, or if it is a base case function calls, then also n operation, because I have to print the entire array, right? So n operations for that. So any function calls typically takes, in the worst case, n operations to perform, n into k amount of operation to perform. That's it. Clear for everyone? Tell me that. Permutations. Sorry. Clear for everyone? The permutation part. Tell me everyone. Revise that once more, right? I will upload the code and video both. Clear for everyone it is? How to generate all the permutations?
Yes, sir, it's clear.
Go through that once more. You may not understand that on the first hand, right? And try dry running on your own. Try have a dry run. Why? How things are operating. Works? Okay. Please revise it and let's meet tomorrow again for the class. Same time. Thanks everyone. Thank you.
Thank you, sir.